Hi everyone, thank you and welcome to today's Trees webinar, RoadEng for Rural Infrastructure. In this web seminar, we're going to be demonstrating the use of RoadEng, a highly interactive civil design software tool for engineering rural infrastructure projects, including roads, site plans, and culverts. Today's specific project is from a U.S. Forest Services location. It's a road washout project, and it'll include a culvert replacement, retaining wall, and realignment of the road approach. So a few pieces of housekeeping before we get started here. First, please feel free to ask questions and engage with us through the Q&A section of the GoToWebinar panel. We'll address all the questions at the end of the webinar. Secondly, the webinar is being recorded and will be available on our YouTube page. If you're a registered, all enrolled registrants will receive an email link to the recording. And last but not least, please be safe and well, considering the situation that we're in. Manager Matthew Dickey will be the presenter and will be demonstrating the use of our software. So he's going to start with importing the project's total station data, and he's going to build a surface model, the digital terrain model, the DTM. He's going to realign the road, setting up a retaining wall component in the template editor, assigning parameters by range, and then we'll address the culvert, get our earthwork quantities, and finally quickly create an output sheet in RoadEng's Multiplot report builder. Sorry, I got a little bit confused here, but without further ado, my part is done, so I'll pass it over to Matt right away.
Thanks everyone for coming out for our presentation today, and this presentation is going to be a little more, it will cover a broader set of topics. We won't go into individual topics as in depth as a kind of a focused example, but yeah, we'll take one right from start to finish. So as Andy introduced, we've got a project that was, it's from Southern United States, and we've got our total station data. So the total station data, just in ASCII format, so comma separated. We've got our point codes and coordinates. Point codes are numbered, so we've got our road edge, we have an R2, there's also an R1 in there, which is nice to make things seamless, and yeah, we'll dive into that after. We'll also introduce the a photo of the site. So we've got our washout, fairly mountainous arid terrain with near surface bedrock, looks to be pretty fractured, and yeah, we'll go from there. So as many of you are aware, we'll create our surface and terrain, and then we'll switch over to do the design of our linear infrastructure in location. So let's insert our file. We've got our ASCII file, okay, and we're prompted with which option we want to use to bring it in. So I've already gone through and created an IOP file for this. So it's an ASCII file, and we control what's what in it. So it's set up so that our second column gives us our X coordinate, our third column gives us our Y coordinate, etc. Point number is first, point code and comment are all on the fifth. That's specified that the data is comma separated, and yeah, X, Y coordinates. Over here in the codes tab, this is kind of where we really make things seamless. So for example, we have R and then the asterisk. So this is saying anything that has an R code with it, whether R1 or R2, so the asterisk is a wildcard character, it's going to be treated in this manner. So we'll have R1 will be one feature, R2 will be another feature, but all of those features are going to have the same symbology associated with them. They'll have the same, they'll all be rake lines, etc. Coming across the top, we can test to make sure things are being read in appropriately. You don't have to do that if you don't want to. It's just nice to check sometimes. Selection, we won't worry about that. That's more for point cloud data, but we will mention projection here. So we're dealing with total station data that hasn't been shifted to a real coordinate system. So we're just going to leave that as an undefined projection. So local coordinates. The project is in feet, so we'll leave it as imperial. And we get this prompt that we're staying in undefined, and that works for me. So there we have it. Since our IOP file was set up well and the surveyors followed the survey standards, everything looks as it should upon being brought in. I'm in the 3D view, and we see we have lines and points, but we don't have a surface. So to create that surface, we'll come up here, we'll click generate, and then we're prompted with a few options. So maximum side length referring to the maximum triangle edge length. We could leave it at 200. We could include all. We might get some funny triangles then, or we can change it to 100. We'll do that. For contours, we'll leave that. 25 seems reasonable to me. It's 25-foot intervals. It's a fairly steep site, so that works. And then our minors are 5-foot intervals. So we'll hit OK, and there we have it. Yeah, so you can see here's our washout. We've got the bank on this side, our existing road. We don't have a centerline feature on this upper road that we're designing, but we do have road edges. So that's perfect. So for now, I think we're done in terrain. Click Save As, save it in here. And then, see our contours in the plan view. Then we'll switch over to location. So in location, we're going to do a new file. So new design. We're going to reference that topo surface that we just created. Washout webinar topo. And then if we wanted to, and if we had one, we could reference the center line, and then each IP along our alignment would reflect a surveyed point on that center line. But we're not going to do that. We're going to just start with a single point in the center of the terrain, and then we'll move things around and fiddle with the alignment right from scratch. And this dialog box is just whether we have an empty template to start or our default template. We'll keep it as the default. So there we have it. Got our plan view, profile view. Profile view is not really showing anything right now because it's just a point, and then our cross-section view. So I'm going to click in our horizontal alignment first. So I just right-click, add edit IP tool, select my IP. So as my cursor changes from the pencil to the box, click once to pick it up, and click again to anchor it. To add additional tangents, I'm just going to click outside of there and add it in. So I'm not going to worry about these runaway fills or anything yet. We're just going to get something roughed in, and yeah, each project can be different. Each designer approaches things different ways, but this seems to be suitable for the project at hand. So we've got our really coarse alignment in there. I'm going to add horizontal curves before we do anything else. So this is our curves panel. If you have the forestry version of the software, there's a good chance that yours doesn't look like this. It probably looks like this, but we can add a bit more function that if you're doing simple designs, you might not need this. So back to what we had. So with this more, the kind of the advanced parameters, we can use the features. So we want a circular curve, and we can assign the radius based on a design speed. We can also auto-populate our super elevation. So I'm going to use minimum curve radius. I'm going to set my design speed to 30. Doesn't fit, so I'm going to move this over a little bit and come back here. Minimum radius 30. That fits, perfect. Hit apply, and then this, just by looking at it, I think I'll want to be out further. We'll set that to be 30, and that still doesn't want to fit. Come out a little further. Oops, wrong button. 30, and then our last curve, we'll no need to change something that's working for us. And there we have that. So just without paying attention to our runaway fills, we've got a pretty significant drop off the side of our road. I'm going to just click in a vertical alignment really quick so we can see a bit better what's going on. So originally it was just a draped surface over the topo. Now we have a vertical alignment that differs from that, so we can see where our fills are. And yeah, I'm going to want to be as tight into this slope as I can, just to limit the amount of fill that we're having to deal with. So I'll pull that over until the curves butt up against one another. So that's, I think, what captures what I want to do right off the start. Before we get into really refining things, I want to address my cross-section. So this cross-section isn't really what I want to show. Doesn't match up with what's actually there. The photo we were looking at, the existing road doesn't really have a shoulder to it. So I'm going to build a template that behaves closer to what we actually want the builders to build. Coming up into the template editor box, we've got the 3 default options that are always there, or at least there when you install the software. I'm going to come over here and pull in the template component folders from the eLibrary. And I'm going to make an entirely new template. I'll call it web road, so webinar road. We'll go -2 and -2 for crown. Override with curve super, so that behaves the way we want it to. And then I'm going to go grab a roadway component that looks closer to what I actually want. So I think rural 9 is the one I want. So no real shoulder, 3 layers though for the pavement. Copy that, we'll paste it in here, paste as new. Now I'm going to configure this the way I want. So our ACP width, we want 10 feet either side of center line. Subgrade width, so this template I grabbed, we specify the top surface width and the subgrade width, and it solves for the appropriate fill slope angle. So I want a 13-foot subgrade width, and for our ACP thickness, I want that to be 3 inches. Same with our base course, and then our sub base, I want it to be 6 inches. So that's that. I want my roadway to be symmetrical, so I've got it configured. I'm just going to copy, paste as right. And next I want to add a ditch in there. So we'll do the standard ditch, copy, paste as new left. I'm going to configure it before adding it to the other side. So it's a fairly arid climate that we're dealing with. So I think we can get by with having a small ditch, so 1 foot deep, and then 1 foot bottom width. Also going to change our ditch slope to be 3:1, so certainly more recoverable than 1:1. And that's that. So just by looking at how things are behaving in the cross-section window, oops, we can test it, and if we move it into cut, there's going to be a ditch there. So that's the way I want it. Copy, paste as new right, and let's go up and grab the standard slope. So slope, that one works for me. Paste as new left. We're going to check what we have here. So this is set cut slope angle at 200, fill slope angle at 1:1. I want to use more of the functionality built into the software, so I'm going to set that to auto. That's good. I'm going to copy that, paste that to the right, and there's our roadway, at least a good starting point for what we're dealing with. We got that assigned. The template that's assigned is still the default template. We haven't adjusted that, so I come up and do assign by range, and I'm going to change that to our webinar road. So dot, 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 it's the entire extents. Now, here we are. Now this fill slope angle, it's set at 1:1, and the driver for that is because of our ground type. So the default ground type is overburden, and it has a fill slope angle associated with it of 1:1, and a cut slope angle of 400%. So that's not what I want here. I'm going to use fractured rock since it's fractured bedrock very close to the surface, and I don't want a fill slope angle of 1:1. I think it's pretty friable material, so let's go with 1.5:1. Where I assign that is up in the assign by range, subhorizons, and we'll go fractured rock right at surface 1. I think it's negligible, any other superficial materials that are there, so we'll just call it all to be fractured rock. Hit that, hit add edit, hit apply, and now our fill slope angle's changed. So that appears to be pretty problematic to me. That would be a lot of work to make that work. If you could make it work, we're down handy to the other roadway as well. We're probably spilling out onto it there. So yeah, we want to do something different than what we have. And as promised, we'll add a wall into our design. I'm going to go back to the template editor. Since this is very close to what I want, I just have a different component I want in there. I'm going to use that as my start point. So copy, paste as new. Now, I'm only going to add a wall where I'm in fill, so I don't care about the ditches. So getting rid of those. And then walls and barriers. Let's grab our Gabion fill wall as our component to start with. We'll copy, we'll paste it in here, so paste as new left, and we'll configure this to behave the way we want it to. So block width, we're going to go 2.5 feet by 2.5 feet. Block offset, we're not going to do an offset, stacking them right on top of each other. And for a batter, we're just going to change that from 15% to 10%. I think that's all we want in there. Just as kind of a good practice, we're going to make this symmetrical. So paste as new right. So I'm just testing to see how things are behaving. It's set up so the blocks are going to be added to the fill, and if we're cut, they're not going to be there. Yeah, so you can see the behavior as we pull things around and see how things are looking. I'm going to change the properties, going to call it WebW, so webinar wall, and that works for me. So just like we did before, we're going to have to make a decision on where to put this wall. Let's go station 1, station 100. or 105 to station. That's probably reasonable. Either, yeah, to station 220. So back into here, templates. Now, our station's going up here, so that's on the left. We only want the wall on the left of our road. So I'm going to go in here. I'm going to assign that to be our wall, and I think I said 105 to 220. Hit OK. And there we have it. Let's just take a quick glance at our 3D view. Now we've got some runaway fills, which make it kind of hard to center on that. Let's just 3D options, use current point. Oh, it looks reasonable. Fairly long wall, but I think that's appropriate. Now these runaway fills, in previous webinars, I've mentioned that the bridge template is nice for things other than just bridges. The reason for that is it's an empty template, so you can make it so we aren't calculating cuts and fills in areas beyond the design. So let's just going to tweak my alignment a little bit more here. Come out a bit. And I'm going to change our extents for that. So we're going to go back to 100, assign by range. And I should probably push that out to 230, or 225 anyway. So 225. So that's that. I'm going to lop our design off right here. So I'm going to add the bridge template beyond 290 and anywhere prior to prior to 125. So here we are taking the corner off a little bit, but we lose reliable topo service beyond that. So that's why I'm going to make the decision to do it there. So assign by range, both dot to, let's do 30. Call that bridge. And I forget the number I said. The other end. 290. Assign by range. 290 to dot bridge. So there we have it. Now, we've got a waterway here as well. So let's address that by adding a culvert. Add, it's a natural channel. And there we go. Now we've got some funniness going on here, and that's because we don't have semi-auto set. So the software is just assuming that the left-hand side of our road is the inlet, which it's not. So if we change that to semi-auto, hit apply, that's culverts going to the upper ditch attachment point. Now, with this, if we refer back to that photo, oh, I guess we don't have to. We've got our waterway here that's kind of filled in, and I assume plugged the ditch and gone over. So I think it's appropriate to add a sump into our design. And let's click properties. So we're going to assign a override of, well, let's start out with something small first. Let's go 5 and 3 feet deep, and 5 and 5. So we can see that all we've done there is add a at a sump. So the ditch depth has been override to be 5 feet deep or 3 feet deep. But given our alignment of the site and the fact that that's already washed out the road, I think the dimensions that we already had are probably pretty close to good. So we want the ditch bottom width to be 20 feet. We'll go with a 5-foot depth, and we're going to make this long. So let's go 25 feet of either side of our culvert, and let's taper it over 12 meters. So there we go. We've got a big hole. We can see that in our 3D view. And yeah, fairly happy with that. Might tweak the skew of the pipe. So let's go 110, see what that does. Yeah, I think that's reasonable. As far as length goes, if you want to change the length, we can do it here. We can go up to, like, do these in nice even numbers, so we can have 50 feet of pipe. Got a hung outlet, but that's reasonably appropriate. So yeah, I'm content with what we're looking at. We have a surplus of material here. We can look at the mass haul diagram. That's been updating as we've moved things around. But I think that's just a case of it is what it is. It's a small site. We don't have a lot of room to balance it along our alignment. If we wanted to, we could play with our sump so we aren't generating as much material in our sump, but I think it's more important for this one to have lots of capacity than it is to deal with balancing our design. But yeah, we'll have to haul away 900 cubic yards of material, but that works for me. So next, we'll jump over to Multiplot. So this is kind of making a formatted drawing. Our Multiplot's organized by a workbook. Inside the workbook, we have chapters, and chapters contain pages. The chapters control the general behavior of the pages within them. So you can have a chapter, for example, that's cross sections, and we can control how those are generated with the parameters in there. Conversely, we can have another chapter for plan and profile, and we can control that there. So this example, we won't build one from scratch. I'll just show one off the web library. Let's just grab that. So we could tweak this. That's a pretty good glimpse of what things look like. I've got a workbook that I like to use. So this is both two chapters put together in the same document, and we'll reference that. So this is an NCD sheet. I'm gonna just change our zoom or our scale. So set that to 200, that to 200, and we'll set this to 100. So a little exaggerated. That looks about right. Over here we have our curve table, earthwork summaries, etc. And culvert summary down here. So we've got length of culvert, culvert diameter, station it's going in. We can also add things like the inlet and outlet coordinates for construction staking if you'd like. And then over here we have our cross-section chapter. So this one, of course, since I've got that bridge template where I don't really care to have any information from it, we can change what's showing up there by going into the pagination and go from, what station does ours start at? So starts at station, let's call it 30 to 290. And back here, whoops, pagination options, 30 to 290. There. So we've lopped off the stuff that we don't care about, and it's still on two sheets, but less clutter. If, I'm not going to go through this, but everything's really customizable. You can change your logo. You could add an image in both sheets, but that's largely what I've got. So yeah, I can just hit print, plot it to PDF, and we have a formatted drawing in our little session here. So that's what I've got, and let's see, do we have any questions? There. All right, so I've got I collect more data and include it after I've started designing, for example, more data points at the end of the alignment. Absolutely. So if, well, let's just go back into our design here. If we had more points, so I'm just going to add something in that's not surveyed at all, but let's just add in a line here. So that's elevation 2764, 2764. So pretend this is real data and not just information that I'm making up on the spot. Add that in. Now we can remodel our surface. So we've got more information there. Then we hit save and come back to our design. We're prompted, do we want to update the modified, do we want to update based on the modifications to the reference file? Continue. And then we've got a little more wiggle room down here. So if you had additional survey data, the premise is the same, but instead of me just arbitrarily drawing lines, you can come in here, hit insert file, and reference in another ASCII file or whatever format you had for your additional data. Is it possible to export the design to a PDF document? Yeah, so we've got that. I'm going to go printer setup. So my printer is set to be a PDF writer, so it's just the same as printing it. I'm going to set my sheet to be RHD, so that matches the design, the formatted drawing size, set my landscape, and hit File, Print, and that'll just save wherever I decide to save it. Next question, good question. Do we need any hydrological data? From the software standpoint, nope. But it's a culvert. It's a real thing. So the 2400, or sorry, 24-inch culvert diameter that I used, that was arbitrary. If I was sizing this and I wanted to have it as small as possible, I would probably use the rationale method or something outside of the software, figure out my drainage area, and use a nomograph or however you want to figure out the size for your culvert. It appears the culvert to shotgun out over the retaining wall. How difficult it is to manually tie the culvert to the cross slope to prevent hanging outlet. So that question is, it's not very difficult at all, but it would be difficult to build in this case. So this is on close to 60% slopes. We don't have to worry about fish passage there. We could address that by changing the culvert gradient. Let's just see here. So if I do that, is that gonna, yeah. So if I change that to auto, it's going to match that up. We can also just play around with different numbers. Oops, let's go 28. So yeah, you can change the gradient manually if you'd like. How do you modify the ground levels? Do you just right-click screen in location to access the menu? Oh, for ground levels over here for our profile, I think I might be misinterpreting this question, but if we want to modify the elevation of the road, it's just the same as we modified here, but we're lucky to have a nice, relatively flat section. You can add additional vertical IPs that way, and you can come into the vertical curve parameter and change your K values to whatever you want. Yeah, so that one's not going to fit as is, just to show a quick example. So yeah, that's that. And just going to undo. There. Someone asked for the if they can have the data to practice. I don't think it would be an issue. Just shoot us an email, and we'll have to make sure it's okay with the folks that gave us the data to use. Is there a template for geotextile reinforced soils in the online library, or is that something we would have to build? There's not a template in there that's explicit to that. Let's see here. I think there's one that's close, though. Actually, I don't have to. Walls and barriers. We've got our subgrade fill, so that's, I think, pretty close to what you're looking for. We've got a reinforced soils. This, we have the soil within the structural component of the DRS wall calculated as another surface. I think we can switch that over. So surface layer 5, we could make that subgrade if you wanted to include that in your mass haul as well. There's a question about using setting coordinates with in here. So we can set our coordinates for our IPs just by cycling through this and updating it here. So I could change my, I'm in the, sorry, horizontal curves. We can set our IPs based on coordinates. Conversely, if you're adding data, and the asker kind of alluded to it as well, we can set coordinates if you're not adding a new survey data in. You can set coordinates for individual points or lines by hitting Control-R. You can add those in. Control-R is the quick key for it. In feature tools, we can also go into, where is it? Coordinates. We can adjust the coordinates for points in our design file. And what I meant by ground level was under the template building section. So, yeah, in the adjusting the different layer depths in the templates. So we come in here. Templates we're using have check marks next to them. So if we want to change something in our WebR, I just double click the parameter that I want to adjust, and we get the parameters option to edit. So if I want to change the depth of my ACP thickness, I can change that in here. So it's in feet, so 3 inches is 0.25 of or 0.25 of a foot, and I made my sub-base thickness 0.5. Similarly for blocks, where's our blocks? I just played with our block dimensions, set it to 2.5 by 2.5. All right, and I think that's everything. We've gone over time, and yeah, thanks for attending our session. And yeah. Andy, are you gonna?
No.
Okay.
I'm all good. Thanks everyone. Okay. See you next time.
Thanks.